We now discuss the solution of a problem from the section Partial Differential Equation that has appeared in the CSIR National Eligibility Test held on 16th September 2022. The problem is related to the Lagrange's first order linear partial differential equation, and the question is from the section C. The given question is, let U be a solution of the following partial differential equation: U suffix x plus x multiplied by U suffix y is equal to 0, and U at x comma 0 is equal to e power x. Which of the following statements are true? We are given 4 options. The 4 options are here. Option 1, 2, 3 and 4. And it is given a partial differential equation. Ux means dou u by dou x plus x times uy means dou u by dou y is equal to 0. With the boundary condition u at x comma 0 is e power x, and u is a solution of this partial differential equation, then which of the following 4 statements are true? That means it can have more than one answer, and it is from the part C. We will now discuss the solution of the problem in detail. We have the partial differential equation ux plus xuy is equal to 0 with the boundary condition u at x comma 0 is equal to e power x. This is a differential equation, partial differential equation, with the dependent variable u and the independent variables are x and y. The given partial differential equation is of the form capital P, small p, P plus QQ is equal to R, where P, Q, R are functions of the independent variables x and y, and small p is dou u by dou x, small q is dou u by dou y. Now, how to solve such and it is a first order linear partial differential equation, and it is called the Lagrange's first order linear partial differential equation. To solve such a first order linear partial differential equation, we write down its auxiliary equations. The auxiliary equations are given by dx by small p, dx by capital P plus dy by capital Q, du by capital R. In our case, its auxiliary equations are dx by the coefficient of ux, that is 1, is equal to dy by the coefficient of uy, that is x, is equal to the whatever the function that is present on the right hand side, that is du by r, capital R, that is 0. Now, we solve these equations and get 2 independent solutions. So first we take the first 2 ratios. Tx by 1 is equal to dy by x, and du by 0, dy by x is equal to du by 0 is same as du is equal to 0. Now this will be x dx minus y dy is equal to 0 and du is equal to 0. Integrating, we get integral x dx minus integral dy, because x dx minus dy, integral is integral x dx minus integral dy is equal to c, and du is equal to 0 after integration will give you u is equal to c1. Now let's do the integration. Is very easy. X square by 2 minus y is equal to c, and u is equal to c1, and take the LCM here. You will get x square minus 2y is equal to 2c. That 2c, keep it as another arbitrary constant c2, and u is equal to c1, and where c1 and c2 are arbitrary constants, and the general solution is given by c1 is equal to phi of c2, where phi is an arbitrary function. Therefore, the general solution of this partial differential equation is u of xy, that is C1, is equal to phi of C2, that is x square minus 2y, where phi is an arbitrary function whose action we have to decide with the help of the given boundary condition. We continue in the next slide. So that's our partial differential equation, that's our condition, and we have obtained the general solution where phi is an arbitrary function. Right. It is given u at x comma 0 is equal to e power x. So get into the general solution, substitute for x only, for y 0, then you will get ux0 is equal to phi of x square minus 2y 2 into y, and u of x comma y is given to be e power x is equal to e power x. That means we have obtained phi of x square is equal to e power x. Now put x square is equal to t, then x will be plus or minus under the square root of t, and therefore phi of t will be e power plus or minus root t. That is the action of phi. Right. Now the required solution is u which is a function of x comma y is equal to phi of x square minus 2y, but phi action we have already determined. So phi of t is equal to e power plus or minus root 2. Therefore, it will be equal to e power plus or minus under the square root of x square minus 2y. So that is your general, that is your solution of the given partial differential equation with this initial condition, with this boundary condition. Agreed. Now let's look at our options. Options have come here. And option 1 is the value of u when x is equal to 2, y is equal to 1. So in this, put x is equal to 2, y is equal to 1, then you will get u at 2 comma 1 is equal to e power plus or minus x square, that is 2 square minus 2 into 1, 2. So this is e to the power of plus or minus under the square root of 2. But it is given e square. So they are not equal. They are not equal. Therefore, the option 1 is not true. Get into the option 2 and substitute x is equal to 1, y is equal to 1 by 2 in this. So you will get u at 1 comma 1 by 2 is equal to e power plus or minus x square. X square is 1 square 1 minus 2y, y is 1 by 2, therefore minus 1. So it is e power plus or minus 0, that is 1, and it is given as 1, and it is same. Therefore, your option 2 is true. Agreed. So now let's take the third option, u at minus 2 comma 1. So that will be e power plus or minus x square, that is minus 2 square minus 2y, that is 2. And that is equal to e power plus or minus root 2. In option 3, it is given e power minus root 2. Yes, this is correct. In the option 4, it is given e power root 2. It's also correct. So therefore, the options given in 3 and 4 are true. So for this question, what is the answer? The answer is option 2, 3, 4 are true. So the answer to this question is options 2, 3 and 4. So that is the detailed discussion of the solution of a problem from the section partial differential equations, which is based on the concepts of Lagrange's first order linear partial differential equations, and it is definitely an easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.